All right, so today we are going to be going over the Energy Skate Park simulation answer key. All right, we're going to be actually starting at part B, where we were looking at the intro section. So we can see from these two graphs that by putting a skater with a large mass high on one side of the ramp, we will be able to get the most potential energy. And this is because a greater height as well as a greater mass will both increase potential energy. Likewise, in order to get the least potential energy, we want to have a skater with a small mass start low on one side of the ramp, because again, a lower height and a smaller mass will give us less potential energy. Similarly, we get the most kinetic energy by having the most potential energy to start. So if we start our skater with our high mass high up on the ramp, once he reaches the middle of the ramp, he will have the most possible kinetic energy. If we have a skater with low mass start low on the ramp, once he gets to the middle, he will have the least kinetic energy. And this would be because he had the least potential energy to start with. When the skater was high on the track, we had the most potential energy and we had the least kinetic energy. As he moved to the middle of the track, our kinetic energy will increase and our potential energy will decrease. At the very bottom of the track, our potential energy will be the lowest and our kinetic energy will increase and be the highest at this point. So then we can say as potential energy decreases, as height decreases, kinetic energy will increase because the velocity or the speed of the skater will increase. So we remember that gravitational potential energy equals weight times height, or we can say mass times gravity times height. So the higher the height and the higher the mass, the greater the gravitational potential energy will be. This also means that the greater the kinetic energy will be as the skater moves down the track. If we look at this table here, we can see how the speed of the skater changes as he moves from the top of the track to the bottom of the track. So we should note that at the highest point of the track, he's not moving yet, so his speed is at 0. And as he goes toward the bottom of the track, his speed increases until it is its fastest at the bottom at 5 meters per second. The claim that we can make about the relationship between energy and speed is that when the speed is low, our potential energy will be high. And as the speed increases, our kinetic energy will increase as well. We know that this makes sense because kinetic energy is 1/2 mass times velocity squared. So because we are multiplying by velocity squared, the higher the amount of speed, the higher the kinetic energy. Two ways that we can change our total energy, which if we remember, is all of the energy in the system, so the kinetic and potential energy combined. We can increase that by increasing the starting height to increase the initial potential energy, or increasing the mass of the skateboarder, which again increases the original potential energy, but that also will increase kinetic energy. Moving down to this table, we can see that as we decrease friction, the motion of the skater increases. So what this means is that when there is friction, potential energy is converted to both kinetic energy and thermal energy. This means that eventually the skateboarder will stop because there will be so much thermal energy that our total energy will have mainly thermal energy, and there will not be enough kinetic energy that will convert back to potential. In the case of no friction, we are not creating thermal energy, which means we can keep transforming between kinetic and potential energy indefinitely. So the claim that we can make about this then is that friction causes thermal energy to arise as a result of kinetic energy being transformed into thermal energy. Again, without friction, we will not have that thermal energy and the skater can continue to move indefinitely. Finally, we have our final track. In this case, on my track, at the very top of the first drop, the potential energy will be high and there's no kinetic energy. The skater's not moving at this point. Halfway down that first hill, we're going to have half potential energy and half kinetic energy. The potential energy is starting to transform into kinetic energy. And then at the bottom of that first hill, we're going to have mostly kinetic energy and very little potential energy. At this point, the speed is going to be the highest on the track. So to summarize, we can say that the higher up the skateboarder was, the more potential energy we had. We can also say that after starting at the top of the ramp, the potential energy was transformed to kinetic energy as a result of the skateboarder's speed or velocity increasing as they went down the ramp. This caused the greatest amount of kinetic energy to be at the bottom of the ramp. Remember, total energy equals potential energy plus kinetic energy, so the system can never have more energy than the starting potential energy. And finally, friction causes thermal energy to arise in the system as a result of kinetic energy transforming. You know to reach out if you have any questions. I hope this video made this topic a little bit easier to understand. Go back and check your document and make any changes that you might need to based on what you learned in this video.